and Assalamualaikum. In this video we are discussing about a question I was taken from a question that I was taking from the calculus by Howard Anton. This is from the chapter of integration principles of the evaluation. So here is the question. So let us read the question first. Recall from the theorem 3.31 and the discussion preceding it that if f-x is positive, then the function f is increasing and has an inverse function. So this theorem just about the inverse function, and it tells us that the increasing function is invertible. The question is given as below. The parts A, B, and C of this problem show that if this condition is satisfied and if f prime is continuous, then a definite integral of f inverse of f can be expressed in terms of a definite integral of f. So the first question is, use the integration by parts to show that the statement is hold. So let us try to do this. First of all, what I'm going to do is we will let u equals to 1. Now we will let that dv. Now I will use the integration by parts. It means that I will use the dv equals to dx, and our u is fx. Then our dv, when our dv is dx, it means that our v is x when we integrate it with respect to x. So now for u, we will get du equals to f prime x dx. So using the integration by part, we'll get a b fx dx equals to fx times x from a to b minus integration from a to b x f prime x dx. So you can evaluate this expression. So we will get bfa minus afa minus a bx f prime x dx. So we have shown this statement is hold. Now we are going to look at this statement, at the B question. This is the question A, and now we are going to look at the question B. Is the result in the part A to show that if y equals to fx, then the statement is true. So now, if you look at this equation carefully, the right hand side is still remained, and this expression will be changed. Now how do we change this? Alright, so we can see that this f is invertible. So now if f is invertible, let's say I was given fx equals to y, it means that x equals to f inverse of f y. Since f is invertible, it obeys the injectivity and the surjectivity of the function. Then we can say that x equals to inverse of fy. Now going back to this expression, this equation, we have a to b fx dx equals to b fa minus a fa. No, I think it should be fb minus a x f prime x dx. So you want to change this expression now. Okay, so now we are given fx equals to y and f prime x equals to dy. I mean dy equals to f prime x dx. We are going to change all this in terms of x into the terms of y, and then we know that x equals to inverse of fy. So if x times f prime x dx, it means that we are taking this inverse of f y and we multiply with dy. But how can we change the limit? So if x equals to a, so y equals to fa, and if x equals to b, y equals to fb. So our integral here ab x f prime x dx is, now you can say that x times f prime x dx is actually equals to this, and we are going to change the limit of the integration when x equals to a, y equals to fa, and when x equals to b, y equals to fb, and the integrand will be as inverse of fy dy. So we'll substitute this into this equation and we'll get the integral of f from a to b with respect to x equals to b fb minus a fa minus integral of fa fb inverse of fy dy. So we just show the equation of the part B. Now we are going to show the part C. So show that if we let alpha equals to f alpha and beta equals to f beta, then the result in part B can be written as given. So now B, we have the integration of f from a to b with respect to x equals to b fb minus a fa minus from fa to fb inverse of fy dy. Now we have alpha equals to fa. It means that a equals to inverse of f alpha, and also we have beta equals to fb. It implies that b equals to inverse of f beta. Since f is invertible, then this statement is true, so then it's not a problem to say that. So you can substitute this you can use this information to substitute into this equation. Then you get f inverse of b beta, and our fb is beta, minus a is inverse of f alpha, and fa is the alpha minus our f alpha is fa is alpha, and our beta fb is beta. And how about this f inverse of y dy? When we talk about the alpha and beta, it means that we are talking about the x. So it's actually we can replace this this y variable into the x just like this. There is no problem about it. It's okay. Now we just change the right hand side of the equation. Now we are changing about the left hand side of the equation. So the left hand side of the equation will be as we know that a is equals to inverse of f alpha, and that b is actually inverse of f beta, and our fx dx can be written as fx dx too. So now we are trying to find this, so you can express this term. So you will get alpha to beta dx equals to f inverse beta times beta minus alpha times inverse of f alpha minus inverse of f alpha, f inverse of f beta, fx dx. So we just show this statement. So now that's all for this video today. Thanks for watching. Thank you.